What's going on everyone, you're back with your boy Jono for another quick math lesson. Today this lesson is an introduction to trigonometry, which is a really scary topic, but I guarantee you're going to find it absolutely fine once we learn the basics in this lesson. There's not a huge amount of maths in this lesson, we're really talking about the language and what we've got to look out for in order to get these questions right every single time. From my teaching experience, this topic has the biggest gap between student assumption, being like, whoa, this is too hard, and how difficult it actually is. I think this is one of the easiest topics you will get all throughout high school maths, but students come into the class being like, nah, too hard for me. I honestly think it's because trigonometry is just a big word. So we're going to go through step by step how to get these questions right, and you're going to see that there's almost no maths involved. The calculator is going to do almost all of the work for us. We really need to do maybe a one or maybe a two-step equation at the very most, but most of this is just looking at triangles. If you can do that, you're going to get good marks. So there are only 6 new words we have to learn to smash this whole topic, and we're going to go through them all in today's lesson. Anything more that we need, the calculator is just going to do it for us. So these 6 words, once we got those under wraps, the rest of the topic becomes incredibly easy. So the first thing we've got to be able to do every single time we get a triangle is label the sides. And if we can do that, we're halfway to learning these 6 words. The first thing you're going to see in these right angle triangles is we've got another angle in there. And this is called the angle of interest. This angle of interest is where the question revolves around. It starts here. So when we label the triangle, it's in relation to this angle of interest. The first side we're going to label is the hypotenuse, which is a word we've probably already seen before in Pythagoras' theorem. So the hypotenuse is just the long side, or it's the one opposite the right angle. The next side we have to label is the opposite side, and this is opposite our angle of interest. It's all the way on the other side. It's as far away as it can be, so I like to remember the O as other. Finally, we've got the adjacent side. This is the last side remaining, but the adjacent side is the other one that's attached to our angle of interest. The angle of interest is always going to be touching the hypotenuse, and the other line that it's touching is the adjacent one because it's attached to it. So for this triangle here, it's actually pretty easy. The hypotenuse is the long side. We're going to throw an H there. The opposite side is all the way on the other side, so we're going to label that O. And then the adjacent one is the other side touching our angle of interest. That's half of what we need to learn for today's lesson. Pretty cruisy. What we do need to know is that the angle of interest can change position just based on the question. For that last example, it was at the bottom, but I could have put it at the top super easily. Some questions actually have 2 angles of interest, and we're going to see an example of that right now. The same skills apply. Hypotenuse, opposite, adjacent. That's all we're looking for. So for this one, we've got 2 angles of interest. One of them looks like a little trident, and the other one looks like an egg with a line through it. So we're going to do our trident one first, and we've still got to label hypotenuse, opposite, and adjacent based on this one's location. So the hypotenuse is still the longest side, so we're going to say that that is the 5. So the opposite from our trident is all the way on the other side, which is that 3, and then the adjacent is the 4, which is still touching our trident side, but isn't the hypotenuse. So still pretty easy. Now we're going to do the exact same thing for our other angle. The hypotenuse is still 5, it's still the longest side, but this time all the way on the other side, or the opposite side, is the 4. And then our adjacent one, the one that's attached to this angle, is the 3. So you can see here that the hypotenuse remains the same no matter which angle we're looking at. It's the opposite and adjacents that switch based on where the angle is within the triangle. So why is this important? It's because there is a relationship between the size of the angle of interest and the side length of that triangle. And I know that this is a little bit abstract as an idea, but we're going to see some examples that really show, yeah, that makes a lot of sense. So let's say we've got this triangle here. We've got angle little x inside it, and on the opposite side, we have a side length x. And down the bottom, we're going to say, oh, this one's just 2. If we have the exact same bottom for the next triangle, so also 2, but instead I'm going to make that angle x way bigger. It's going to open up the triangle a lot. What I've got to do in order to make this triangle still meet is make that side length x way bigger. So making the angle bigger makes that opposite side length bigger as well. And this works in reverse. Let's say I close that angle down, make little x really small. well then I don't have to go as high to make the triangle fit. So that means the side length x also goes down. We can also see that the hypotenuse changes as well. It's not just the opposite side. The hypotenuse has to get bigger or smaller based on the size of the angle, because it's got to meet back up and actually make a triangle. So these two things are related. We can see from these examples that there is a relationship between the size of the angle of interest and at least two of the side lengths. And what trigonometry does is try to quantify this relationship. The relationship is described by three trig ratios, and these are the next three things we need to learn for this lesson. They look a little bit weird, but we're going to get into them in this lesson and learn a couple of tricks to make sure we remember them. So the first one is called the sine ratio, and the sine of an angle is equal to the opposite side divided by the hypotenuse. This thing sine is just a mathematical equation that the calculator will do for you. All we need to know is that the angle size is in relation to opposite divided by hypotenuse. The next one is the cosine, or cos, of an angle is equal to the adjacent over the hypotenuse. So we can see really quickly why labeling the sides is incredibly important, because it tells us what ratio to use. Finally, we've got one called the tangent, or tan, of an angle, and that's equal to the opposite over adjacent. So we've got three ratios that we definitely need to learn, and they're based on the three sides that we can have. So the easiest way to remember these ratios is with this mnemonic, so, ka, toa. What that's saying is sine is opposite and hypotenuse, SOH. Cos is adjacent and hypotenuse, CAH, and then toa is tan, opposite and adjacent. I would actually like you to write it like this. I know it looks a little bit weird, but hear me out. Now I know that sine is equal to opposite over hypotenuse. The fraction's already written for you, so you can't forget it. Then cos is adjacent over hypotenuse, and tan is opposite over adjacent. I would highly recommend writing this down for every single trig question or test you do, just so you can refer to it, because there's no way you can make a mistake if you know exactly what the ratios mean. So how does this look in a question? All we've got to do with a triangle is work out two things. What sides do I have? And what ratio does that mean? So the first thing I do for every single question is label the sides. So the hypotenuse is 6, so I'm going to write an H next to the 6. Then all the way on the opposite side from my angle of interest is the 4, so I'm going to label that O, and then the adjacent doesn't have a number with it. Because there's no information there, I'm going to ignore the adjacent for this one. So the two sides that I've been given information for are opposite and hypotenuse. That's half the question already done. All I've got to do now is work out which of these ratios I use. Because I've got O and H, I know that it's going to be sine, SOH. So that means to write my equation, all I've got to do is sine of the angle is equal to the opposite divided by the hypotenuse. So 4 divided by 6. In the next couple of lessons, we're going to see how to get an actual answer from this. But if you can set this equation up, you're like 90% there to getting full marks for trigonometry. We're just going to do one more question here where I've got my sides and I've got to label them first. So I've got 12, that's the hypotenuse, so I'm going to write an H there. And then touching the angle of interest is that 8, so I'm going to write A. That means I've got A and H. Looking at my ratios, I've got cosine, or ka. All I've got to do now is write cosine of the angle is equal to 8 over 12, and then the calculator is going to do the work for me in the next lesson. So there are only 6 things you need to know to smash this whole topic. Don't get freaked out by trigonometry. If you know 6 words, you can do the whole thing. So we've got our sides, hypotenuse, adjacent, opposite, pretty easy. And then we've got our 3 ratios, sine, cos, and tan. We also have a really easy way to remember these 3 ratios, so ka toa, and I would highly recommend learning this and writing it down for every question you get for trigonometry. Thanks so much for watching this lesson, guys, and I'll see you later.